It's me, Mario! Not really. I'm not Mario. I'm just Mr. Ellis. Surprise! So today is interesting because what I want to teach you is anti-math. Yeah, down with the system. So this is like the opposite of math. So the whole idea here is like, well, what do we do if I have a multiple choice problem and I don't know how to solve it? Like, this is a systems of equations problem that's kind of difficult, and you don't remember how to do systems of equations, and you don't remember how to do pretty much anything at this point in the year. And so you get a multiple choice problem and you don't know how to do it. What shall you do? A, randomly guess. That's cool. B, don't do anything and just skip it and go to sleep, and that's not cool. That's lame. Or C, do this and get it right, probably. So this is a cool trick that you can use anytime you have a multiple choice problem. We're going to do it using systems of equations, but it'll work for anything when it's just an equation that you're solving and you have multiple choice. What we're going to do is we're going to take the possible answers that we have and we're just going to plug them in to the problem and see if they work. So it's like we're going backwards. Instead of solving the problem and getting the answer, we're going to take the answer and plug it in to see if it's possibly the right one, I guess. So for systems of equations, it works like this. A system of equation has two answers. It has an x and a y. X and y. X and y. And the way that you typically see the answers written is x and y, just like that. So when we solve for this, what we're going to solve, the way we're going to do it is we're going to take the x value, that's the first number, and we're just going to plug it in where the x is, and then we're going to take the y value, and we're going to plug it in where the y is, and if it gives us something that works, we know that that's the answer. If it gives us something that doesn't work, we know it's not the answer. So we're just going to try all four of these and see which one works. It's like cheating, but it's legal. So that's awesome. So if I take the first problem here, marker, got it. So if I take the very first problem here, it says the x value is -1. So I'm going to take the -1, I'm going to put it in for x. 11 times -1 minus 6. And it says the y value is 5, so I'm just going to put the 5 over here. Now you've got calculators. You can use a lot of calculator stuff for this and make it even easier. I'm a math teacher, so I don't use calculators. Yes, I do. I use calculators sometimes too, but not this time because it's too easy. So when I simplify this out, again, if you want to type that into your calculator, like 11 times negative, where is it? 11 times -1 minus 6, that's really hard to do backwards. If you want to type that part into your calculator and it'll give you -17, that's cool with me. And what you'll find is that you're left with 5 equals -17. Well, that's not true. You're right, it's not true, so that's a bad answer. That can't be it. So then we try something else. Let's do the 1 and the 7. I don't know why I just pointed to the screen. So if we do 1 and 7, that means the x value is 1 and the y value is 7. So I'm going to do the exact same thing. I'll just use this first equation. Why not? So the y value is 7 times the x value is 1 minus 6. If I do this, 7 equals 11 minus 6. 7 equals, what is 11 minus 6? 5. That's not working either. That's poo-poo. So that one doesn't work. So we can cross that one off of our list. Then we go to the next one. 5, 1. Well, 5, 1. That's my x value. Let's put that in for x. Here, I'll use a different color. I'm running out of room. Hopefully you wrote better than I did. So if I do the 5 right there, put it in for x. 11 times 5 minus 6. I should get an answer that equals y, which is 1. And I can already tell you this is not going to work because that's 55 minus 6. And that's not going to be 1. That's going to be 49. So at this point, I already know that the last one is my answer. But let me just show you just to prove it to you. Because you may not believe me. And that's okay. I'm not afraid of you. And your unbelief, I'm here to prove myself. So I will use blue because that's a good one. So what if we put a 1 where the x is and 5 where the y is? Well, that would be 5 is where the y is, equals 11 times the 1 minus 6. So 5 equals 11 minus 6. Oh, what do you know? That's true. 5 does equal 5. That one would work. So if I put this where that is, that's going to work. Now this is a systems of equations, so we want it to work for both of them. Go away. Go away. There we go. So let's try the second one too, just to make sure, or just so I can prove myself further. Y equals negative 6x plus 11. Let's see what happens. If I put the 1 where the x is, that'd be negative 6 times 1 plus 11. And if I put the 5 where the y is, because that's the y value, it's right there, then that would be 5. So 5 equals negative 6 plus 11. Well, type that in your calculator, negative 6 plus 11, and you get, that's right, 5. So that's how we know that that's my answer. So that's just solving used by not really solving. That's just plugging things in to see which one is going to work, which is a neat skill to have, and it's also going to save your tail on a test when there's or at least on a multiple choice test. If you don't remember how to do stuff, you can just keep doing this all the time, and it'll eventually work. So I want you to go ahead and finish the rest of these, plug things in, see if they work, and if they work, good, and if they don't, cross it out. And if you are a little bit confused and you need to rewind this video, you can do that. Go back and listen to me talk again, and maybe it'll work that time. Or you can ask me questions. Good luck, folks. I'll see you next time in math class.